In the previous video, we talked about the scientific notation and how do you convert the numerical values or decimal values into the scientific notation or the standard form, which is it's called. And in this video, we'll talk about how to convert the standard form, which is basically the scientific notation, back to the numerical form or decimal form. So this video will be about converting the standard, which is the scientific notation standard, to numerical decimal. So first we're gonna start with the values that are greater than 1. We'll start with the values that are greater than 1. So let's say we have, so before starting, for before going through the examples, uh, it's 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 so for you to know that for the value for the problems for the scientific notations whose values are greater than 1, the introduction of adding zeros will start on the right side of the digits, and when after the digits are already written, and then we will start with the zeros. It is only applied for the values that are greater than 1. So what do I mean by that? So let's have an example, shall we? So the example here is, the first example will be 3.0 multiplied by 10's power 8. Now here what I'm talking about, that in the values that in standard form, the scientific notation, the values that are greater than 1, the zeros will be introduced after the digits are written, and the zeros will be on the right side. So what do you mean by that? Well, let's say let me choose another color here. I think green will be perfect. So we will write 3 as it is. We will write 3 as it is. Now here, oh, I'm sorry. We will write 3 as it is. The first digit will be as it is. Now here we have 0. So if there is only 0 present here, we're just gonna neglect it. But if there is a non-zero digit here, then we will also write it with it, and then we will introduce the 0, and after that we will write the zeros. So here we have only 3, then we will write first the digit 3, and then we're gonna look at the power, which is the power of 10. So what's the power of 10 here? It's 8. Oh, I think I chose the wrong color here. So what's the power of 10 here? 8. So this basically means 8 zeros. So this the power of 8, the 10's power will determine the number of zeros. So in this case we have 8 zeros, then we will introduce 8 zeros here. So what's the answer will be 3 followed with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And that's how you convert the standard convert standard form, the scientific notation, to back to its numerical value. Let's have another example. So this example is a step up to the first example. We have the problem, we have the question, or we have the scientific notation here. We have 8.793163 multiplied by 10's power 6. So here, let me choose the green color here for explaining to you. So first digit will be written as it is. We will have 8 here. Now, as I told you before, that here we had only 0, so that's why we neglected it. Now here we don't have any 0, and we have non-zeros here. We have 7, 9, 3, 1, 6, 3. We don't see any 0. We don't have any zeros. Well, even if we have zeros, we're not gonna neglect these values. It will be only, this case is only applicated because of this, because there is only 0 present here. That's why we neglected it. But in case we will not neglect it, and we will write it down besides 8. So these digits will be written 8, 7, 9, 3, 1, 6, 3. Now let me just clarify, not clarify, just for the simplicity, for the sake of your explanation. Now here we have written the digits as it is, and here we have tens power. So what's the tens power here? So tens power is 6, which means 6 zeros. But how do we write zeros here? Because in this case we neglected it, and that's why we put the zeros here, 8 zeros here. So here we have the decimal point, and after that we have numbers here. We have 6 numbers here. So how do we introduce these 6 zeros here? Well, in this case we're gonna look at this decimal point here. So the method will be that for tens power 6, this basically means that we will move only applicable for values greater than 1 in scientific notation, for values that are greater than 1. So here we will move the decimal point 6 digits to the right side here. So we will move it to 6 digits on the right side. So how many digits? 6 digits as determined by the tens power, 6 zeros. That means 6 digits we're gonna move to the right. So here the decimal will have to jump to 6 digits to the right. So here we have 1, 2, 3, 4, 5, and 6. So the decimal point will jump here, and then we have the decimal point. So decimal point at the very end of the right side is just meaningless. You can just neglect it. So we have the final value 8793163, and that's the answer here. Let's consider another example, which is basically the extension of this example. And where should I write? I think I will write it here, just to clarify, just so you can see this scientific notation too. Because it's only the extension of it. So we already know that decimal is was at this point, at on the very right side of it, after we have introduced the digits. But it jumped across 6 digits because we had only 6 zeros. So what if I write the same scientific notation, 793,163, multiplied by tens power, and instead of writing 6, what if I introduce 8 instead of 6? So we have tens power 8. So here we already know the decimal was at the very end. So we neglected it because it does not affect the final value. So what about this? What about 8? So let's find it out. We're gonna use the same method as before. Write 8 as it is, along with all its digits. 8. Oh, sorry. I have to change the colors here. 8, 7, 9, 3, 1, 6, 3. Now look at this power, tens power 8, which basically means 8 zeros. 8 zeros. So how we will deal with it? Okay, 8 0, and we have decimal point, and after that we have non-zero digits. So we already know we have to move the decimal point to the right. But how many digits? We know it's gonna be 8. So let's count it. 1, 2, 3, 4, 5, and 6. So we're gonna jump, the decimal point will jump to the right side here. But there's a problem. What is that? That it only jumped only 6 digits, and here we have 80. Basically means that the decimal have to jump 8 digits, but instead we only have 6 digits. So what here we're gonna do it, that the rest of the zeros, which is 8 minus 3, 8 minus, oh, not 8 minus 3, sorry, 8 minus 6, because we had only 6 digits to jump to the right, for the decimal point to jump to the right. So 8 minus 6, we have 2 remaining, 2 zeros. So what we will do with it, we will just introduce the 2 zeros here. Here we will introduce 2 zeros here, and that's the answer for it. As long as soon as the as soon as we have the final digit for the decimal point to jump to the right side, and even if you have ran out of the digits, but the power of 10, is still greater, then we will have to introduce zeros. For example, here let's say we have, instead of 8 we have 9, then we have to use, when then we have to introduce another zero, which for this case will be 3 zeros, and so on. So that was the thing. And now the final example, not final, let's after this we have the final scientific notation. Let's have another 7 2 3 5 5 3 4 multiplied by 10's power 4. So how do we do that? With this same case here, writing 7 along with the digits, we will have 7 2 3 5 5 3 4. And I've just made a mistake. I'm really sorry. I have to write it in blue color. 7 2 3 5 5 3 4. So how do we write where do we introduce the decimal point? So let's here we have 4. 4 basically means move the decimal point 4 digits to the right. So here we have 1 2 3 4. 4 digits we're gonna move to here, 1 2 3 4, and we will introduce the decimal point here. Where was it? 2355, 2355. So here we will introduce the decimal point here. So let's have another example, and this will be the same as this one, so I'm gonna write it here. We have 2.3333 multiplied by 10's power 4. So the same thing, I'm not gonna use the green pen here, because you have already know the method. So for meaning move 4 digits, for move the decimal point 4 digits to the right side, and here we only have 4 digits to jump. So here we will have the simple answer. We will have 2 3 3 3 3, and this will be the answer for it. So this was for the values that are greater than 1. So what will be for the values that are less than 1? So we will talk about that, shall we? Now we will have, I think this is perfect. Okay, so we will now talk about the values that are less than 1. Values less than 1. So let's say let's consider the following. Let's consider some problems here. We have, let me introduce some scientific notation. But first, let's let me just explain it to you for what to do with the values that are less than 1. So in this case, we will introduce the zeros before the digits themselves at the left side, and then we will write the digits at the end. So in the uppercase here, that values greater than 1, we introduce the zeros after we have written the digits. And here, where did we write the zeros? On the right side here, obviously. Here will be the exact opposite. Here what we will have, we will introduce zeros first, and then, which is basically on the left side, we will introduce zeros first, and then on the end we will write the digits here. So let's have the let's have an example. We have 7.0, 7.0, mind you, minus 6, 10 with 10's power minus 6. So how do we deal with this? So as I already know, this is the simple example as from the very first example. For the values that are greater than 1, 7 will be written as it is, and 0 we already know. No matter how many zeros here after the decimal point, if there are 4 or 6 or many zeros, if there are only zeros, then we will neglect it all. But if, for example, we have 7.000000001, that means we also have to write it down here, because it has a number, it has a digit that is a non-zero. But if we have everything zero, then we will not write it, we will just neglect it. So here we have 7, we will write 7. Oh, um sorry, I made my mistake here. So here, instead of writing 7, what was the rule? We have to write it at the end, at the very end. So zeros will be introduced first. Hmm. I think I have to write the conclusion, not the conclusion, so a method at the very end, just for to clear you all guys. So first we will go through the examples here. So how do we deal this? So here we have 10's power minus 6. So we will have to introduce zeros first. So how do we introduce this? And before this, I also remembered, um, before trying to introduce zeros first, I have to explain it to you guys. That's something that we have 10's power 1, which is basically equal to 1 and equal to 10. So what is 10's power minus 1? Well, obviously it is 0.1. So what's the 10's power minus 2? Well, this is 0.01. So what's the power of 10 minus 3, which is equal to 0.001. So here the point I'm trying to make it here, that here we have basically a simple step here for 10's power, for the power that is in positive. Well, obviously here we have 1. If even we have 10's power 3 or 4, we know that after writing 1, we have to write the number of zeros that are determined by the power of 10. But in this case, we have 10's power minus 1, and you have to see that 0.1 here, 0.1. So we don't see any zeros after the decimal point. We know that there is 0 on the very left side, but we're gonna just neglect it, but for reasons I will explain it to you in the very end. And here we have 10's power minus 2. We can see that is there is only one zero, and for 10's power minus 3, we can see there are only two zeros. So how do we address this problem? How do we solve this problem? Well, for this, you will have to count the decimal point as well. So when we talk about 10's power, for example, 10's power minus 4, 10's power minus 4. So here we will count the decimal point as well. We will start with the decimal point, 1, 2, 3, 4, and then we will introduce 1. So that's how gonna be. And some of you will be saying, Well, we can obviously select this 0 here on the left of the decimal point, and your point is valid too. But I will encourage you to stick with the decimal point here, because obviously in the in the future videos that I will cover, and I think I will make two more videos for the scientific notation. For complex scientific notation operation like arithmetic operations, we have to keep the decimal into account of like moving the decimal point. So the zeros at the very first that are introduced at the very first or at the very last of it after the decimal point here on here we have 0, and then we have introduced the decimal point. So the 0 does not make any sense. We can also neglect it, and it will not change this value. And also the same thing as well here. For example, we have 100 and we introduce decimal point, and here we introduce the decimal and the zeros. It will not affect this value. So what I'm trying to say is that this zero on the left side will just cause you confusion, and that's why I encourage you to stick with the decimal point. Count it as a part of 0. So with this picture in mind, let's do the with 10's power 6. As I already told you that zeros will come first, then we will write it. So how we will write it? As 0 point decimal point, count it as a part of 0, as count it will start counting from here. 1, 2, 3, 4, and 5, 6. So with the decimal point we have 1, 2, 3, 4, 5, 6, and then we will introduce 7 here. So that was the trick in order to solve for the values that are less than 1. It's just that you have to count the decimal point as well. So here we have with the decimal point we have 1, 2, 3, 4, 5, and 6. So that's how we will do it. Now we will have another example for you. So let's have another example. 5.826 357 multiplied by 10's power minus 2. Well, that's easy. We will have to introduce only one zero with also counting the decimal point. So first introduce the zeros. We will have 0, then decimal point 1, 2, and then we have the values 8, 5, 8, 2, 6, 3, 5, 7. Let's have another example. So this will be a pretty simple one, where all the examples are very simple because they are written in scientific notation. So this is the only there is only simple trick, a simple method for it to write it in decimal form. So what will be the result of it? Let me just explain it to you with the green marker. -4. So what we will introduce here, we will introduce decimal point with 3 zeros. So 0 point decimal point taken as so counting from the decimal point 1, 2, 3, 1, 2, 3, and 4, and then we will have 1, 3, 3, 3, 3. So this is the final. This is the answer for this scientific notation, and this is basically it for the values that are less than 1. There's a simple method for it, while on the values that are greater than 1 we encountered some problems, like you can see at the second at this problem where we have to deal with the decimal point moving to the right side, and then and here we had only the exact value, but because we had only 6 digits to move from, and we also had 10 power 6. But here, if we raise the power to 8, then if you have only limited digits, for example here we have 6 digits to jump from, so the power of 10 minus the digits jump, the remaining value will be added as zeros here. So that was the case for the values that are greater than 1, but we didn't encounter something like that in the values less than 1. well well, it's mostly due to the fact that we have here 10 power 6, which is basically, if we take two parts of it, we just split two parts of it, we have this part here, we have this part here, we know that 10 power 6 is a big number as compared to just 8.793,163, right, basically. But here we have 10's power minus, for example 10's power minus 2, we have very small numbers. The 10's power is very small as compared to the other numbers here. For example, we have 5.826357. And why didn't we encounter problems something like that is only because of the fact that these examples are purely on if the values are already in their standard form, or precisely or accurately speaking, in scientific notation form. So that's why we didn't encounter this kind of problem. So what was the simple rule for it? What was the general rule for scientific notation? With the general rule was that the first digit, as explained in the very first video of it, first digit will be a non-zero. So first digit will always will be a non-zero, then followed by a decimal point. So that's how you understand it. You look at their standard form, and from the moment you look at it with these two rules, you can check whether that form is actually correctly written in scientific notation in standard form or not. So now I have to conclude here. I think I should conclude here because I told you guys before. um so here we will write values greater than 1, and we have values less than 1. Just to make a point here, and I will not write this whole thing down here, because it will take a lot of space, plus I explained it to you recently, and it's okay not to get it in the first try. You just watch the video again. It's kind of complicated at first, but it's really really simple when you get the hang of it. So what I want to write here is, let's say we have green. Okay, we have green here. So values greater than 1, we will have first write digits, and write write zeros if any are given. Like for example here we didn't have any zeros. Then write zeros, and when will be the zero introduced on the right side. So what will be the values that are less than 1? So less than 1, we have the rule first write, again I have to write the z in this character. First write the zeros, then write digits, which will be obviously on the, well, not for not for the digits, well, for the zeros, which will be obviously on the right, on the left side. So this is the video as it is, and this is only for, as I told you before, we didn't encounter problems as here we had for this scientific notation and this scientific notation for the values greater than 1, and here we have values less than 1. We only have simple methods. Also only because of these whole problems are in standard form, they are correctly written in standard scientific notation. So what if they are not correctly written in scientific notation? What if we have to correct it into proper scientific notation? So how we gonna do it? So that will be for the future video. I will explain it to you guys, how to detect, how to see if the scientific notation is indeed correctly written, and if they are not correctly written, how do we correct them. And I will introduce another method for it. That will be a very general method for it. It might be a bit complex for you at first, but it will be easy. Now, in the previous video and this video, I only talked about methods, but that in the next video I will just introduce a general rule, and from that rule you can convert the numerical or decimal values to standard to scientific notation, or back to scientific notation to back to numerical. So that if you get that method, that will be easy for you. And the only reason that I try to use to explain it to you guys using these methods, because they are just very easy. And then if you go on the upper level with that journal loop, which might be complex for you guys at first, you can actually check it for yourself, like comparing it with these methods, and you can just get the hang of it more quickly. And after that video is covered, that will be the correcting the scientific notations. Then we will move to the arithmetic operations for the scientific notations, and the next two videos will be only based on the new method that I will explain to you guys. And I think that this wraps up the whole video. I've taken half an hour of your time. I'm really sorry about it. And I think I think this might be it for these examples are enough for you guys. And if you like this video and found it informative, then don't forget to like this video, share it to your friends or any other person, and please subscribe to my channel. And this really helps my channel, and just pushes to and just pushes the channel to more audience. And thank you for watching this video, and I'll see you guys in the next video. Thank you.